Energy efficiency. The need for it in the United States is no secret. Ever since the energy crisis in 1973, people have been working on ways to save energy. With more fuel-efficient cars, new technologies in illumination, and better insulation in buildings and homes. It's in our own houses, mobile homes, and apartments that all of us can save energy and save money. By efficiently weatherizing dwellings, people can often save 20 to 30% on their utility bills. This investment is often out of reach for low-income families, the people who benefit most from the savings generated by lower energy costs. And that's where we come in, the New Hampshire Weatherization Assistance Program. For over 12 years, the local community action agencies through the Weatherization Program have helped low-income families in New Hampshire. These families benefit from vast improvements in technology to not only insulate houses, but also improve the comfort and safety of the people who live there. How? That's what we're here to talk about today. We're going to look at the methods we use to conduct a thorough audit of individual houses to determine what's needed. Then we'll take a look at the kinds of things we can do to enhance the efficiency and comfort of those same houses. Finally, we'll examine the cost-effectiveness of these measures. Let's look at the process. After a homeowner has qualified, a certified energy auditor comes in to do a complete energy audit of the property. That audit includes a thorough inspection of the furnace and any other combustion appliances, checks for moisture problems and adequate ventilation, and blower, door, and infrared tests to find the areas in the house that need additional insulation or tightening. These tests will also show whether the house is too tight already. Once that audit is complete, we then come in to do the work that has been recommended, keeping financial payback in mind. But let's start at the beginning and take a thorough look at the entire process. Here are 3 homes. The first house is an older one, heated with a gas-fired furnace. It has a full basement which is unheated. The second one is a newer house, heated with an oil-fired boiler and forced hot water. The furnace is supplemented by a wood stove. And finally, we'll investigate a mobile home, heated with forced hot air from a kerosene furnace. All 3 homes present their own problems, but illustrate one key point. The home and its occupants are a system. What you do in one spot affects everything else. For example, too little air exchange may cause moisture damage, or even a dangerous buildup of poisonous gases. All of us used to just weather strip the windows and throw more insulation in the attic and feel we'd done the job. But there are advanced technologies to make it possible to pinpoint the problem areas and then make appropriate changes to balance and improve the entire system. So Tim, what do you plan to do at the outset?
First, we'll check all the combustion appliances. See if we have any problems before considering any other work.
So how do you do that?
Come on, I'll show you.
We're really going to look at 2 primary issues with combustion systems: the efficiency of the heating unit itself and the kind of safety problems that can result from an improperly running or installed unit. With an oil system, we first check for fuel leaks. Check the chimney. Check pump pressures. Replace nozzles. Clean the system. And check safety equipment. For example, our auditor made sure there's a thermal cutoff switch.
Next, we'll check the boiler efficiency.
Okay, what's the technique?
We'll drill a hole in the flue pipe and take a sample of the flue gases. Then we'll compare that reading to this chart, and we can get the efficiency of the unit from that. The test must always be taken from the flue pipe.
All right, can we see it?
Sure. The first test that we'll do is we'll take a smoke test on this unit. We'll run our test. Next, we'll check our filter paper sample against this chart. And as we can see, this unit is burning fairly dirty and needs to be cleaned.
With a gas furnace, the auditors also conduct an efficiency test by sampling the flue gases. Obviously, fewer emissions mean a cleaner environment. Okay, but furnace efficiency isn't the only concern with combustion appliances. I know a major worry is carbon monoxide. A poorly tuned furnace, or one not drafting properly, or unvented gas stoves and heaters can actually allow dangerous carbon monoxide into the house. How do we check for that, Tim?
We test for carbon monoxide in a similar manner by testing the flue gases. Later, we'll check other combustion appliances. If we find that the combustion appliances are producing more than 50 parts per million, we will have the unit serviced.
Great. Now we're going upstairs to take a look at the next step in the New Hampshire weatherization process, the blower door test. The key to insulating any house is to reduce air leakage, but we found that air leakage in buildings is caused by many combinations of factors. The stack effect. This form of heat loss is caused by warm air in the building rising up to the top and leaking out through cracks and openings. Outside air is then pulled in at the bottom of the house to replace the leaking air. Wind effect is just what it sounds like. Heat loss caused by the wind. It can greatly increase the air exchange rate of the house. Most houses, however, now suffer little heat loss from the wind. The flue effect is more problematic. The gases from the furnace which are expelled up the vent must be replaced by air from the outside. Mechanical ventilation, exhaust fans, dryer vents, and so forth, increases the air exchange rate. Air that is vented must be replaced by outside air. Finally, forced air distribution systems such as forced hot air furnaces with leaking supply and return ducts can greatly increase the air exchange rate in the building. This is also true when air supply ducts are isolated from the returns. These problems can create large enough negative pressures to backdraft combustion appliances into the house. The blower door test is a key one. We can't begin to find out where the problem areas are in a house until we analyze them in a scientific manner. Now, Tim, tell me, how does this test work?
Okay, we place this fan unit in this exterior door. Then we go around and close all the other doors and windows. Then, using these gauges, we depressurize the house to 50 pascals. The more air that we have to pull through the fan, the leakier the house is.
How's this house doing?
This house is doing pretty poor. It's going to need a lot of work.
Can we find the leaks?
Sure, we can use this smoke stick and our common sense, and we'll be all set.
Oh, let's go find them.
Okay.
The attic is one of the real problem areas in a house, particularly around the chimney and the plumbing stacks. The flow of the smoke is pretty strong here. We'll need to take care of this spot. We checked around the house to find other areas that were leaking into the house. Exterior walls, near windows, around stairwells and ductwork, and so forth. This drawing shows many of the points where leakage can occur. The energy auditors examine as many as possible. In conjunction with the blower door, another procedure that the New Hampshire Weatherization Assistance Program does is infrared scanning. The infrared scanner is particularly helpful in diagnosing problems of convective heat transfer as a result of what are called convective loops and bypasses. These problem areas are often much more important than windows or doors. Convective loops involve the transfer of heat from warm interior surfaces to areas where cold air occurs in adjacent building cavities. Examples include dropped ceilings over stairwells, around cabinet openings to the attic, uninsulated bulkheads, or partially insulated walls that allow air to circulate around batt insulation. Bypasses present similar problems. Houses turn out to be full of air paths and chaseways that allow heated air from the house or basement to flow around or bypass insulation into the attic. These kinds of bypasses include chimneys and plumbing penetration and balloon-framed walls. Infrared scanning can help find the problem areas. The New Hampshire Weatherization Assistance Program is not only concerned with insulation. Health and safety are also considerations. One of the auditor's key interests is moisture. Too much moisture can be an indoor air pollutant. It can lead to the growth of molds, spores, and mildew. And the potential for moisture-related structural damage is greater as the humidity level increases. There are really 4 kinds of moisture of concern. Bulk moisture, which is caused by rain, runoffs, groundwater, and the like, is the greatest source of moisture in the home. It can also come from showers, combustion appliances, houseplants, and even from people breathing. Moisture problems can also result from air leakage. As a result, condensation from a warm building can collect inside a wall cavity or attic. Capillary moisture leakage is the kind we usually get in our basements when water rises up in a porous wall. The 4th type is similar but involves diffusion through surfaces. This was once thought to be a major source of moisture in the home, but is actually one of the least. But moisture is not the only health and safety culprit. We also take a good look at structures to see if they're adequately ventilated. In our attempts to increase the efficiency of buildings, problems may have been created. These problems could affect the quality of the air we breathe. Many things can cause unacceptable air quality. Combustion byproducts such as nitrous oxide, carbon monoxide, and moisture can be released from unvented space heaters, water heaters, ranges, and gas dryers. Formaldehyde from new building materials, radon, asbestos, lead dust around windowsills, volatile organic chemicals from cleaning products, and even dust and pollen. It's not hard for the auditor to detect the presence of these problems, but combustion gases are more of a problem. For these, the energy auditors use a digital carbon monoxide tester. This handheld device checks for CO gas levels in all areas of the house. So, now we know a great deal. We know the areas in these houses that need more insulation. We know where the moisture problems are and what kinds of health and safety concerns exist. In fact, the certified energy auditors have turned up a great deal of information. The question now is, what does the New Hampshire Weatherization Assistance Program do about all this? The first priority is health and safety. No other measures can be done if problems exist. Let's look at what can be done. If there is an unvented stove or furnace, it must be vented or removed. The chimney must be in good condition, and the draft must be checked before any work is done. Moisture control is another health and safety issue. The best strategy here is source reduction. The fact is there are a number of methods for correcting moisture problems, but in all cases the certified energy auditor will make the appropriate recommendations. Radon and asbestos can both be more serious health threats and both require action by the homeowner. Finally, it's important that houses, apartments, and mobile homes be adequately ventilated. The blower door test indicates not only where air sealing is needed in a house, but also if the house is actually too tight. In that case, additional ventilation might be needed. Now that all the testing is complete and we've either corrected the health and safety issues or made appropriate recommendations, we can now go on to actually insulating the house or mobile home. The New Hampshire Weatherization Assistance Program stresses two things: cost effectiveness and payback. A short payback has always been our goal. Since the heat loss in a building is a combination of conduction, convection, and radiation, fixing only one area can result in disappointing savings. Remember, a house is a system. Adding insulation in the attic may reduce heat loss, but if the walls have no insulation, a major source of actual heat loss remains. Therefore, we begin by insulating the building walls. The key point is that insulation should form a continuous barrier to heat flow. Therefore, particular attention should be paid to the interstitial junctions within the structure. We make sure that the wall insulation fills the structure of the wall area. In most retrofit situations, that means that blown-in insulation, densely packed, will be used. It is important to reduce air leakage with a product that decreases conductive heat loss. A dense pack insulation will also reduce the chance of moisture problems caused by air leakage. After insulating the walls, the next area of importance is the attic. Again, adding insulation may reduce heat loss, but if the bypasses and chaseways in the attic aren't sealed, another major component of actual heat loss will remain. If you want to keep heat in a container of any kind and at the same time prevent air from rushing in at the bottom, the best thing to do is put a stopper in the top. And that's just what attic air sealing does. So let's watch how they proceed with the attic. After inspecting the area for moisture, workers will install a fireproof air barrier at all chimney penetrations from the cellar to the attic. This generally consists of high-temperature caulk and flashing. The chimney is also blocked with unfaced fiberglass prior to installation of cellulose insulation. All pipe chases, wire chases, open-framed interior partitions, and any other similar areas are sealed with caulking or foam sealant. It is important to locate recessed lighting fixtures, electrical junction boxes, chimneys, and any other heat-producing equipment in areas where insulation is to be installed. These areas all need to be isolated to prevent contact with the insulation. It is important not to block soffit vents at the eaves and other sections of the attic. The idea is to allow free movement of air, but not allow that air to wind-wash insulation and reduce its effectiveness. This is important because air movement through insulation will reduce its R value. Generally, we use blown-in cellulose loose fill with an R value of 30. Not only is it less susceptible to the wind effect, but has the added advantage of being made from a recycled material. It is very important to properly seal all heating system ductwork with high-quality mastic. Duct tape should not be used. Finally, it is a good idea to seal off the bulkhead if there is one. Considerable infiltration of outside air can penetrate the house through the bulkhead door.
We now finally get to work on the areas where many people begin: windows, doors, dryer vents, and so forth. Though many people tend to focus upon these areas because the tasks are simple to do and inexpensive, we've already found that these measures by themselves contribute in only a small way to the overall cost savings in weatherization. Mobile homes present a slightly different set of problems to be addressed. The walls are generally thin, there's a big airspace underneath, and the roofs offer a small attic. Newer mobile homes do have increased wall space, now generally 2x4s, but little insulation. Because there is so much air movement around the walls, we recommend stuffing bats of insulation into the space.
Duct leakage is a major problem in mobile homes. Finding and sealing these leaks is a top priority. Moisture can also be an important consideration because of the nature and shape of the mobile home, so fiberglass insulation is required. If cellulose insulation gets wet, it absorbs the moisture and could eventually break through the ceiling of the home. Finally, it is important to limit the flow of moisture underneath the structure. Sheets of polyethylene are effective in retarding diffusion of moisture from the ground.
Energy savings is not the only issue. It's also important to consider cost effectiveness when we're weatherizing a house. When we're determining cost effectiveness, we use the blower door test and the auditor's on-the-job experience to determine when enough air sealing or insulation is enough.
The blower door test is actually done after each stage of work on the house. The auditors have an air passage cutoff point of 1,350 cubic feet per minute through the blower at 50 pascals. But not every house can get to that limit. So, as they are air sealing, the contractors make a judgment about the improvement made. If the reductions are small, then it is not cost-effective to continue air sealing the structure.
It's a subjective judgment to a degree, but our contractors have long experience in building insulation, and with the guidance of the blower door test, arrive at a balance between doing further work and the dollars that will be saved. Our contractors have now finished their work. They've not only insulated the house, but have provided important improvements in the areas of health and safety. But at the New Hampshire Weatherization Assistance Program, we don't consider the job complete until we've done a backdraft test. As mentioned before, this check lets the auditors know if any combustion gases are being drawn back into the house.
We go around the house and turn on all exhaust equipment, the furnace fan, exhaust fans, and so forth. Then pressure measurements are recorded from this gauge. We're looking at the pressure differential between the outside and the inside of the building. If the readings show too much negative pressure, the house may be too tight. The exhaust fans may be too powerful, or the air system may be out of balance.
And that's it. The auditors do a final quality control check to ensure that the work has been done properly. The New Hampshire Weatherization Assistance Program has accomplished quite a bit. We've conducted thorough energy audits of these houses to determine the weatherization needs. We've identified the kinds of things we can do to enhance the energy efficiency, comfort, and safety of these houses. And finally, we've made sure that the improvements were cost-effective. But best of all, we've been able to help low-income families save energy and money while improving the comfort level of their homes. Naturally, these improvements can benefit all homes. We've learned how the New Hampshire Weatherization Program uses the latest technologies to produce a warmer, more comfortable, and less expensive home environment for New Hampshire's low-income families. The New Hampshire Weatherization Assistance Program, saving energy and helping people.